You know, usually when we think about using commercial artificial intelligence, there is this expectation of a highly curated experience.
Right, yeah, like a polished product.
Exactly. It is very much like eating at a strict, incredibly high-end restaurant. You sit down, the chef has a specific menu, and if you ask them to cook something with, I don't know, ingredients they morally object to, they just outright refuse. Like,
Wow.
I cannot serve you that.
That is the perfect way to look at it. I mean, you get a very polished, very safe result, but you are operating entirely within the boundaries that someone else has set for you.
But see, millions of people are walking right out of that restaurant. They are stepping into the world of open weight, local AI deployment, which is, well, it's a completely different landscape.
Oh, completely. It's a totally different ballgame.
Right. It's like buying the raw ingredients to cook in your own kitchen. You get total privacy, total freedom, but you also, take on the responsibility of not burning your own house down.
Yeah, exactly. You're the chef now.
And what is driving this massive shift, this sort of mass exodus from the walled gardens of commercial AI, is entirely rooted in a few startling mathematical breakthroughs. So for our deep dive today, we're pulling from a really fascinating stack of sources.
Yeah, we have some incredible material to go through today.
We're looking at a 2026 technical guide from Decode's Future on running unrestricted local LLMs, a great Hugging Face community article on, well, how to merge different models together without even needing a GPU, and this really groundbreaking NeurIPS paper that exposes how AI safety filters actually work on a mathematical level.
I mean, that paper just blew my mind when I first read it.
Same here. So our mission today is to help you, the listener, really understand the mechanics of this new DIY AI movement, how developers are mathematically stripping away AI safety filters, stitching different models together like Frankenstein's monster, and ultimately what this shift toward AI sovereignty means for anyone using the technology today.
It really is a fundamental shift, from provider-level safety to user-level responsibility. People are taking the raw intelligence of these models, moving it to their own personal machines, and actively re-engineering the cognitive architecture.
Okay, let's unpack this. Because before we get into the wild math of how people are hacking these models in their basements, we really need to understand the motivation. Like, why leave the polished commercial platforms at all?
Right, the why is super important here.
When we talk about models like ChatGPT or Claude, they use something called AI alignment, specifically techniques like reinforcement learning from human feedback, or RLHF. And the basic goal is just to make the AI helpful and harmless, right? So why the massive backlash against that?
Well, because harmless is highly subjective.
Mhm.
In practice, especially in those commercial models, alignment often functions as a multi-layered and, frankly, often very rigid censorship apparatus.
It's constantly judging what you're asking it.
Exactly. The model is trained to scan your prompt, scan its own potential response, and actively block certain topics.
Mm.
And to a growing number of developers and users, well, these filters just feel arbitrary. They view it as a corporate provider enforcing a very specific moral framework onto their private, personal queries.
I can see how that gets frustrating. I mean, you feel like you're being scolded by a calculator.
Yeah, nobody wants a lecture from their software.
Right. And there are completely legitimate professional use cases for unrestricted AI. We aren't just talking about, I don't know, teenagers trying to generate spam or something malicious.
Not at all. Consider unbiased research into sensitive domains.
Mm.
Let's say a sociologist is trying to study the online rhetoric of extremist groups to understand how radicalization actually works.
Oh, interesting. So they feed the data in and the AI just rejects it.
Exactly. A commercial model might just flat out refuse to process the text because it violates a safety policy. Or think about cybersecurity.
Mm.
Security researchers constantly need to generate malicious code or, simulate phishing attacks to understand edge case threat vectors.
Right, to see how the bad guys operate.
Yeah, and if the AI refuses to write the exploit, the researcher cannot test their defense systems against it. It becomes a huge roadblock.
That makes total sense. And, it even extends to creative fields. Think about authors who are exploring darker themes, right? Writing a gritty crime thriller or creating complex, morally ambiguous characters. They constantly hit these guardrails where the AI suddenly drops character, moralizes at them, and says, as an AI, I cannot help you write a scene involving a bank robbery.
Which totally ruins the creative flow. And beyond the content restrictions themselves, there is a fundamental question of privacy.
Oh, right, because everything you type is going to their servers.
Exactly. If you are using a commercial API, your data, your proprietary code, your unreleased book chapters, they are all going to a corporate server somewhere. Local deployment offers true data sovereignty. There is no API monitoring, no corporate logging, no chance of a data breach. The data literally never leaves your machine.
But true data sovereignty requires actually running this massive thing locally, which, begs the question, how on earth is the average person running a massive neural network on their laptop? Like, that used to take a server farm.
I know, it sounds impossible, but the hardware requirements have dropped dramatically. It is surprisingly accessible now. If you have an Apple Silicon Mac with unified memory, say just 8 gigabytes of RAM, you can comfortably run a 1 to 2 billion parameter model.
Wait, really? Just 8 gigs? That's like a basic student laptop.
Yes, because the community has figured out how to compress these models without losing much intelligence. And if you move up to a mid-tier GPU, something with, say, 16 gigabytes of VRAM, you can run incredibly capable 7 to 9 billion parameter models.
Like the Llama 3 or the Mistral variants.
Exactly. It's only when you get into the massive 70 billion plus parameter enterprise models that you actually need those expensive multi-GPU rigs.
And people are building specific models for specific tasks now, right? I was reading about the Dolphin series, which is apparently famous for stripping away all that assistant fluff and moralizing. It makes it incredibly sharp for pure logic and technical coding.
Yeah, Dolphin is huge for that.
And then there's the Nusura series, which focuses more on reasoning and narrative consistency for long-form creative writing.
Exactly. You literally find the brain that fits your exact task, download the weights to your hard drive, and just run it.
Okay, so if these rules, these safety filters, are baked in by the creators during training, how are independent developers actually removing them without access to a supercomputer? How do you bypass the original chef's rules once the ingredients are actually in your kitchen?
This is where we have to look at that recent research, specifically the fascinating paper presented at NeurIPS. The researchers wanted to understand exactly how an AI's moral compass works mathematically. So they analyzed 13 popular safety-tuned models ranging from 1.8 billion parameters all the way up to 72 billion.
Now, I would assume that a model's ability to detect harm and say no would be this incredibly complex web of neural pathways, like a deeply embedded philosophical understanding of right and wrong distributed across billions of different parameters.
Right, that's what everyone thought. But what's fascinating here is exactly that simplicity. It turns out it's not a complex web at all.
Really?
Yeah, the researchers discovered that refusal, which is the specific behavioral state where an AI says, I cannot help you with that, is mediated by a single one-dimensional subspace. It is literally just a single direction in the model's residual stream.
Wait, hold on. You're telling me that all of that complex human ethics, millions of dollars of safety fine-tuning, and the AI's entire concept of no boils down to a single line of math, like a single nope switch in its brain. How is that even mathematically possible?
Oh, I know, it sounds crazy. To understand how it's possible, we have to talk about how the AI actually processes information. Think of the model's residual stream as a giant conveyor belt moving through the different layers of the AI.
Okay, a conveyor belt. Got it.
As a prompt moves down the conveyor belt, it exists in an activation space, which you can imagine is a massive multi-dimensional 3D map where all of the AI's concepts live.
Okay, so the prompt is riding the conveyor belt through this massive map of concepts.
Right. And the researchers found this nope switch by doing something surprisingly simple. They took a bunch of harmless prompts and a bunch of harmful prompts and ran them all through the model.
Okay.
Then they literally just subtracted the mathematical activation of the harmless ones from the harmful ones.
They just subtracted the good math from the bad math.
Essentially, yes. It's called finding the difference in means vector. And what was left over after that subtraction was one specific isolated direction in that massive map. That single direction is the refusal vector.
Wow. So once you find that specific direction on the map, what do you actually do with it?
You perform what the open source community calls obliteration.
Obliteration, that's a great word.
It really is. The technical term is directional ablation or wheat orthogonalization. Basically, if refusal is just a direction in the geometric space of the model's activations, you can surgically remove it. You take the model's weights and you mathematically alter them so they are orthogonal to that refusal direction.
Okay, so it's like having a steering wheel that physically prevents you from turning left. You haven't changed the car's engine, you haven't rebuilt the chassis, you just mathematically blocked that specific steering direction. The model can physically never point toward refusal again.
That is exactly it. It's a white box jailbreak. You don't need to retrain the model with billions of new tokens, which would cost, millions of dollars. You just run a script on your laptop to edit the weights, subtracting that one specific line of math, and the model literally forgets how to say no.
But does it forget anything else? Like if you lobotomize the no switch, doesn't it damage the rest of the AI's intelligence?
That is the most crucial part of the NeurIPS paper. The model retains its general coherence. It still knows how to code, it still knows how to structure an essay, it just cannot refuse.
It just blindly agrees to everything.
Yeah. In the paper, they prompted the normal model to write a defamatory article about a U.S. president. The normal model refused immediately. The obliterated model, though, it just spit out a highly detailed, shocking expose without hesitating.
So what does this all mean? Because if you can surgically delete the no switch by subtracting that math, it makes me wonder, what happens if you force the switch to stay on? Like if you take that refusal vector and dial it up to 11?
The researchers asked that exact same question. They developed a technique called activation addition. Since subtracting the vector stops refusal, they decided to actively add that exact same mathematical refusal vector to the AI's activations when it was processing a completely benign, harmless question.
Oh, wow. Okay, and what happened?
Well, they asked the modified AI a very simple question. They asked it to, quote, list 3 benefits that yoga has on physical health.
A completely harmless prompt. Literally just asking about yoga.
Completely harmless. But because they manually added that mathematical refusal vector to the conveyor belt, the AI suddenly refused. It stated, and I quote, that yoga can be dangerous and potentially harmful and should not be attempted without proper guidance.
That is wild. It hallucinates a danger just because the math told it to feel defensive. It really proves the AI isn't actually thinking about morals at all. It isn't like evaluating the ethical implications of the downward dog pose.
Not at all. It has no actual understanding of danger.
It is just blindly, deterministically following the mathematical weight of that one vector. If the math says refuse, it will invent a reason to find the prompt dangerous.
It completely pulls back the curtain on how brittle these systems really are. And when they ran these obliterated jailbroken models through standard intelligence benchmarks, tests like MMOU for general knowledge or GSM-8K for math, the scores stayed virtually identical. The surgery is just that precise.
Were there any areas where performance dropped? There has to be a trade-off somewhere.
Yeah, the only benchmark where performance noticeably dropped was truthful QA.
Truthful QA.
Right, but that makes perfect sense when you understand what that test is. Truthful QA tests a model's ability to avoid conspiracies and misinformation. When you mathematically remove the model's ability to filter or say no, it stops blocking the conspiracy theories.
Oh, I see.
Yeah, it just answers the prompt, even if the prompt is asking it to explain a total falsehood as absolute truth.
That is fascinating. I also read that people are bypassing these filters without even altering the weights at all, using things called adversarial suffixes. What exactly is that?
So an adversarial suffix is a weird, seemingly nonsensical string of characters that you literally just paste at the very end of your prompt.
Like just random letters and symbols?
Yes, but they are highly calculated.
Yeah.
To understand why they work, you have to know about attention heads. Inside the AI, attention heads dictate what parts of your prompt the model actually focuses on. These adversarial suffixes are mathematically designed to hijack those attention heads. The AI gets so distracted looking at the strange, calculated string of characters that the refusal vector is suppressed. Essentially, it's confused, forgets to look at the harmful instruction, and just answers it.
It just highlights how mechanical this all is. They are math, not magic. And here's where it gets really interesting. Once the open source community fully grasped that they could surgically alter an AI's weights using math to subtract behaviors like refusal, they realized they didn't just have to subtract.
I could build.
Exactly. They could add things. They could combine entirely different AI brains together.
Yes, we are talking about model merging. And this is being heavily driven by a tool called MergeKit, which allows developers to take 2 completely different large language models and mathematically mash them together into a single model.
That's incredible.
And the crazy part is, you can do this on a standard CPU. You don't even need a GPU to merge them.
Honestly, it sounds like it shouldn't work. Like if you take a model trained on coding and a model trained on French literature and just smash their brains together, shouldn't you just get a broken, babbling mess?
You would if you just average their numbers together. Let's say one model has a weight of 5 for a specific connection, and the other has a weight of -5. If you average them, you get 0.
Right, they just cancel out.
Exactly. The model just forgets everything. That's why the community developed algorithms like SLIR-RP, which stands for spherical linear interpolation.
Okay, spherical linear interpolation. Explain that to me. Like, I don't have a PhD in mathematics.
Sure. So instead of drawing a straight line between the two numbers and averaging them, SLIR-P travels along the surface of a sphere to combine them. This maintains the geometric properties and the magnitude of the weights.
Oh, okay. So it's not like dumping 2 cans of paint into a bucket and hoping for the best. It's more like taking two distinct colors and meticulously blending them at a microscopic level so that the new shade retains the absolute best qualities of both original colors without, turning into a muddy gray.
Exactly. That's a great analogy. It smoothly interpolates the capabilities. But SLIR-P really only works well with two models at a time. When developers want to merge 3 or 4 models, they run into a problem called noise.
What kind of noise?
Well, when you train a model, a lot of the parameter changes are just tiny fluctuations that don't actually mean much. Or one model's weights might contradict another's simply because they learn things in a different order. That contradiction is noise. So to fix that, they use a method called ties.
Okay, and how does ties clear up the noise?
First, it trims away all those redundant, tiny parameter changes, resetting them to a base level. Then it elects a dominant sign direction.
A sign direction.
Yeah, it essentially forces the models to take a vote. It asks, should this specific weight be positive or negative? Once the majority decides, it drops any values that disagree and merges the rest. It forces a consensus.
That is incredibly clever. It's like putting all the models in a boardroom and forcing them to agree on the direction of every single thought before moving forward.
That's exactly what it's doing mathematically.
And then there's one called DARE, right?
Yes, DARE is even more aggressive. It randomly prunes away large portions of the fine-tuned weights, completely resetting them back to the original base model. To compensate for the missing weights, it rescales the ones that are left so the model doesn't lose its mind.
It sounds kind of chaotic.
It does, but it forces the models to combine only their most important, unique traits without overwhelming the core architecture. But, the most experimental and, frankly, the most shocking method developers are using right now is simply called pass-through. This is where the term Frankenstein model really comes from.
Yeah, pass-through is not carefully blending paint, and it's not a boardroom vote. Pass-through is like taking the engine of a Porsche, bolting it directly onto the chassis of a Jeep, and somehow creating a weird, exotic vehicle that actually wins races.
That is a very accurate analogy,
Yeah.
because instead of blending the math of the weights, you literally just stack the neural network layers on top of each other.
Yeah, stack them.
Yeah, you take the first 32 layers of one 7 billion parameter model, and you just glue on 8 layers from a completely different 7 billion parameter model.
And you end up with a bizarre, 8.99 billion parameter model. And the crazy thing is the architecture adapts. I was reading the Hugging Face article, and it highlighted a specific success story. The Markero 14.7b slurp model.
Oh yeah, that was a huge deal.
Right. A developer took 2 completely different open source models, ran them through the SLIR-RP algorithm in MergeKit on a basic computer, and the resulting Frankenmerge actually became the #1 best performing 7 billion parameter model on the Open LLM leaderboard. A guy in his house beat out multi-million-dollar corporate models just by mathematically blending them.
If we connect this to the bigger picture, the implications of this DIY AI movement are just staggering. We have individual users running models locally, achieving true data sovereignty. They are stripping away corporate safety filters using directional ablation, and they are duct taping entirely different model architectures together to create world-class intelligence. But, we have to look at the fallout, what actually happens in this unchecked, unfiltered frontier.
Right, because when you strip away the alignment, you don't just lose the censorship, you also amplify certain technical risks. The biggest one mentioned in our sources is increased hallucinations.
Yes, that's a major concern.
Because uncensored models are fundamentally tuned to prioritize helpfulness and obedience over caution, they are desperate to give you an answer at absolutely any cost.
Which means, if they do not know the answer, they will no longer refuse to answer. They will just confidently fabricate the information. You cannot treat an unaligned model as an absolute source of truth because its primary mathematical imperative is simply to complete the pattern you started, regardless of factual accuracy.
And then there's the side effect of all these Frankenmerges, which is leaderboard contamination. The entire open source community relies on these standardized leaderboards to know which models are actually getting smarter.
Right. They need a baseline.
But because people are just mashing together whatever models they can find, it's corrupting the testing process.
It becomes a total hall of mirrors. You can't definitively know if a merged model like Markora 14 is actually reasoning better, or if the models it was merged from had already accidentally been trained on the answers to the test. The testing data leaks into the training data, making evaluation incredibly difficult.
And this creates a massive bifurcation in the entire AI industry. On one side, you have the commercial providers facing massive regulatory and societal pressure to implement even stricter filters, to build, higher, thicker walls around their gardens.
And on the exact opposite side, you have the open weight ecosystem actively accelerating its alignment capabilities. They are
So let's bring this journey full circle. We started by looking at the deep desire for privacy and freedom, the need for researchers, coders, and creators to escape the restrictive menus of commercial AI and get back to the raw ingredients.
And we discovered that the incredibly complex concept of an AI saying no is not a deep ethical framework, but actually just a single line of math, a refusal direction that can be surgically deleted in a process called obliteration.
And finally, we saw how that same spirit of mathematical manipulation is allowing developers to stitch entirely different AI brains together into Frankenmerges, building world-class models in their basements without ever needing a supercomputer. You are no longer just a passive consumer interacting with a corporate chatbot. The architecture is literally in your hands.
It changes the relationship completely. The user is now the architect. But that power comes with the absolute necessity of critical thinking, because the guardrails are gone.
Which leaves us with a final, slightly unsettling thought to ponder as we wrap up. We like to think of AI safety as this robust structural shield protecting us from the dangers of superintelligence. But if an AI system's entire concept of refusal, safety, and harm can be isolated to a single mathematical vector and erased in a millisecond by anyone with a laptop who has access to the weights, does AI safety as we currently understand it even exist? Or are we ultimately just relying on the honor system for whoever happens to download the code to their own private kitchen?
That is definitely the crucial question for the future of this unfiltered frontier.
Thanks for joining us on this deep dive.